Hello viewers, welcome to Abiben Tutors. Today we have an interesting problem on projectiles which is on the board and we are going to solve it together. We are given that a ball is projected horizontally from the top of a building with a velocity of 10 meters per second. The height of the building is 45 meters. We are asked to determine number one, the time taken by the ball to reach the ground. How long will it take the ball before it lands? And then the second, the distance of the ball from the building after hitting the ground. Remember, this ball is projected from a height and which happens to be a building. So when it drops, okay, what's the distance from the foot of the building to the landing point of this ball? And then for the third requirement, we are asked to find the direction of the ball to the horizontal just before it hits the ground. We are given acceleration due to gravity to be 10 meters per second square rather. Now, before we go any further, I'd like to say one or two things here. Whenever a body is projected horizontally from a given height, we treat such bodies as bodies under free fall. So that will help us know what appropriate equation to use in the first part of the problem. So let's do it together. And then for solution here, we have been given initial velocity. We've been given initial velocity. And that we represent with small letter u to be 10 meters per second. And then the height of the building, we are told the building is 45 meters tall. So the height, 45 meters. Next thing we've been given is the constant acceleration due to gravity. So we are given the constant to be 10 meters per second. So like I said, we will treat the body as one under free fall. So we recall from uniformly accelerated motion that height, okay, equals to half gt squared. This is a formula applicable to objects or bodies that are falling freely from heights. We've been given the height in this case as 45 meters, so we substitute that. And then acceleration due to gravity is 10. And then we square our time. Half of 10 is 5, so we have that 45 equals to 5t squared. The coefficient of the square term here happens to be 5, so we shall divide both sides by that 5. When we do so, we end up having 45 divided by 5 equals 5t squared divided by 5. Okay, so this 5 will divide itself and also do away with the coefficient of the square term. 5 will divide itself. It will divide 45 9 times, because 5 times 9 gives us 45. So we have that t squared equals to 9. To remove the squared, or the power 2 rather, we take the square root of both sides. Every time you have a power 2, you take square root of both sides to isolate whatever you need to find. So in this case, we take the square root of both sides. When we do so, we will have that t equals to square root of 9. And that's equals to what? 3. Remember, square root of a number is supposed to be 2 values. But since we are dealing with time, we will drop the negative value and go with the positive value alone. So square root of 9 is 3. Therefore, the time taken for the body to drop, which is the time of flight, is going to be 3 seconds, okay? So therefore, time taken to drop or hit the ground, whichever way, is 3 seconds. That is it. Now, in the second part of the problem, we are asked to find the horizontal distance where the ball lands and the foot of the building. Was the horizontal distance there? Having known the time of flight, 3 seconds from the first part, and also the initial speed of launch, which is 10 meters per second. So we will have that distance. The distance we can represent that with x is going to be what? U times t. Okay? And our u in this case is 10 meters per second. and then time is 3. So that gives us a horizontal distance to be 30 meters. So that means the object or the ball lands 30 meters from the foot of the building. Interesting. The next thing we need to obtain is with what direction, what's going to be the direction of the ball when it touches the ground. Because when the ball lands, if this happens to be the ground, you are going to have a ball that comes this way, okay? So when it lands, what is going to be this angle? That's the theta we are expected to find in the last part of the question. All right, so we will do that once again together, and we would complete all what is required of us. Okay, so we'll sketch a diagram. If the ball drops, it will be under the influence of two speeds, the horizontal speed, which is the initial speed of launch, and also the vertical speed, which is going to be our final velocity. If you remember from triangle law of vectors, we can isolate a right angle triangle for the problem, where here will be v, the final speed, here will be what? U, the initial speed. And if we were to find the resultant, we would draw the arrow or the direction of the resultant from the tail of the final speed here, and it will end at the head of the initial speed. But in this case, all what we need is just angle theta. Take note. We just need to find angle theta, that's all. So final speed for vertical motion under gravity, v will be equals to g times t, where g is acceleration due to gravity, t is the time, and then that will be 10 times the time of flight. We just calculated that to be 3 seconds, okay? So that gives us 30 meters per second. So that's the final speed. And when we substitute that in this triangle, like we have it here, we end up having this. It's a right angle triangle, take note. It's a right angle triangle. So here is now 30 meters per second. Here is what? 10 meters per second. And here is what? Theta. So what trig ratio shall we use that would make do with the opposite side of the triangle and also the adjacent side? That's going to be tangent. So tan theta equals to opposite, which is 30, over adjacent, which is what? 10. And if you do away with the zeros, we end up having 3. Okay? So theta, tan theta equals to 3. Theta itself will be tan inverse of 3. Okay? So tan inverse of 3, we would do that together. Use your calculator, activate the second function, and then tan inverse of 3. That gives us 71.57 to 2 decimal places. So that becomes 71.57 degrees to 2 decimal places. Therefore, the distance or the angle with which the ball lands is 50 or 71.57 degrees. Therefore, angle, we can call this angle of landing. Angle of landing is 71.57 degrees. Please do well to share, like, and follow us, okay, for more tips.